Hi, in this video I am going to discuss Edexcel IAL Mathematics Mechanics M2 June 2022 paper. All the questions will be discussed in this video. Okay, so first question, it's based on vectors. So you should know basic things related to vectors. For example, if A is a vector and it is given by a straight line, vector could be shown by a straight line with an arrow. The length of the straight line indicates the magnitude and the direction of the arrow indicates the direction of the vector. For example, A is a vector and it is shown by this straight line. The length indicates the magnitude of the vector and the direction. We can give it in terms of angle also, that indicates the direction of the vector. So the magnitude of the vector is denoted by this way. Okay, unit vector. What is the meaning of unit vector? Means just one unit for a particular vector. How to find the unit vector? For example, unit vector along this direction. How to find it? Unit vector along this direction is given by vector A over magnitude of A. If you divide the given vector by its magnitude, you will get the unit vector along that direction. So that's a unit vector along the same parallel line. We can say its length is just one unit. But normally we have well-defined unit vectors in Cartesian coordinates. We normally denote by in 2-dimension I and j. In 3-dimension we use I, j, k. Generally we take I along the direction of x, j along the direction of y. So in Cartesian coordinates we can show the unit vectors, this direction I, this direction j in 2-dimension. Okay, say for example, a particular vector is given by a vector, say for example, vector A is given by 5i plus 4j. So what's the meaning of it? Along the I direction, that is along the positive x direction, its length is, or its magnitude is 5. So if I say this is 5. Along the y direction, j direction, its magnitude is 4. So 5i plus 4j means this is the given vector. So the vector A is this one. Along the I direction, unit vector I, that is 5 units. Along the j direction, its unit is 4. So actual vector A is this one. This is the actual vector A. So what could be the magnitude of A? That is given by square root of 5 square. If you consider Pythagoras theorem, this is 5, this is 4. So the length of this line, that is the magnitude of the vector A, is given by Pythagoras theorem by using 5 squared plus 4 squared. You can solve it and get the magnitude of the vector A. What could be the direction of that vector? Theta, if I say, tan theta is equal to 4 over 5. That is value of j unit over 5 I. That is the direction. From that you can find the theta, tan theta. From that you can find the theta. Okay. For a motion of a particle, we can represent its position by a vector. For example, at an instant, at a particular time, the position vector of a particle is given by r equal ai plus bj. Means same way, along the I direction, its unit is a. Along the j direction, its unit is b. So its magnitude is square root of a square plus b square. The direction of that particular position vector, tan inverse b over a. We can find that way the position vector. When it is given, we can find its magnitude and the direction. And a and b could be in terms of time. They could be a function of times. For example, a could be given as 2t squared plus 4t, 4i. J could be given as 4t cubed plus 6t squared j. Something like that they can give the a and b in terms of t, the function of t. Okay, so you know the position vector of the particle at an instant at a particular time t. Okay, to find the velocity of that particle, differentiate the position vector. That is, the velocity vector is given by differentiating the position vector dr over dt. So if you differentiate, it's going to be, for example, in this example, it's going to be 4t plus 0 I plus 12t squared plus 12 tj. Okay, so the velocity vector now is given by 40I plus 12t square plus 12t, 12t square plus 12tj. Now, if they ask to find what could be the velocity at particular time, say for example at 2 seconds, substitute the value t2, you will get the velocity at that instant. And if you want to find the magnitude of the velocity at particular instant, at a particular time t, okay, magnitude means magnitude of the velocity, or that's a speed at an instant. So find the magnitude of the velocity vector v, that is square root of 4t squared, square root of 4t squared plus square root, we have to take 12t squared plus 12t all things squared square root. Okay, if you solve it, you will get the magnitude of the velocity or the speed in terms of time. If you want to find the speed at an instant, substitute the value of the time. For example, at 4 seconds, what's the speed? Substitute t4, then you will get the speed at 4 seconds. If you want to find the direction of the velocity at a particular time, that means in terms of angle, if you want to find, that is the direction. So same thing, tan theta is equal to, same idea, tan theta equal 405. So 405, this is if I say this vector r equal to ai plus bj means tan theta is equal to b over a, tan inverse b over a. So same way, tan theta is equal to 12t squared plus 12t over 4t. 12t squared plus 12t over 4t. If you solve it, you will get the direction or the angle of the direction of the velocity with respect to I direction. Okay. Sometimes they give the velocity vector, or you might need to find the velocity vector, and they give the direction vector of they give the vector direction vector. Okay, so the direction vector and velocity vector doesn't matter, they should tally. Say for example, if they give something like this, say velocity vector is given by v is equal to, for example, u1i plus u2j, u1i plus u2j, that's a velocity vector given. So u1, u2 could be in terms of function of time, doesn't matter, it's a velocity vector. Now directional vector is given, the directional vector is given by the direction, there is a directional vector or direction is given by, it's given as for example ai plus bj, the direction of the velocity vector is given, directional vector is given as ai plus bj, means from this one we can find the magnitude of the velocity, that is speed also. But if you want to find the direction here, tan theta is equal to u2 over u1. This is directional vector of the velocity. So here also tan theta must be the same, v over a. That means both should have the same value. So u2 over u1 must be equal to v over a. From this, you can find the unknown whenever that's depending on the question. So whenever they give the directional vector, that won't have magnitude, but you can find the tan theta from the directional vector like v over a. But velocity vector, by using it, you can find both direction and the magnitude of the velocity, that is the speed also could be found. So there, if the velocity vector is given like this, the direction of the velocity is given by u2 over u1, that is j component over I component divided, that gives the direction or angle with the I direction. Then directional vector of the velocity is given as ai plus bj, means the direction is v over a, where both should be the same, means u2 over u1 should be equal to v over a. Okay, that's all you must know related to vectors. Based on that, the first question based on this idea, we'll do that now. Okay, so first question, at time t seconds, where t greater than or equal to 0, a particle P has a position vector r meters with respect to a fixed origin O, where r, this is the position vector is given in terms of I and j unit vectors, and the position vector depends on time also, it's a time function. Find the acceleration of P when t equal 4. Acceleration of p, the particle is p, at time t equal 4. So what to do? We have to differentiate this position vector with respect to time. You will get the velocity vector. When you differentiate the velocity vector again, you will get the acceleration vector. So in acceleration vector, you substitute the, they are asking to find the acceleration. So they are not asking to find the magnitude of the acceleration. So they are asking to find the acceleration when t equal 4. So that means in terms of ing, you have to find the acceleration vector, which includes ing with a direction. But we are not going to find the specifically the magnitude of the acceleration or specifically direction of the vector. We are going to find the acceleration vector. Okay, so differentiate twice. So that means velocity vector is given by dr over dt. So that will be differentiated 3t square minus 8I plus this 3 comes from 133, they will get cancelled. So t squared minus 2t plus 2j. So this is the velocity vector. Acceleration vector is dv over dt. Differentiate the velocity vector again with respect to time. So it's going to be 6t minus 0, that is I, plus 2t minus 2, this will become 0, j. So this is the acceleration vector in terms of time. So they asked to find the acceleration at 4 seconds. T equal 4 means it's a vector. So at t equal 4, or when t equal 4, so this acceleration vector a is equal to, substitute 4 into t, 624I plus 4 into 2, 8 minus 2, 6j. So 24I plus 6j. But if you want, that's answer. That's what they're asking to find the acceleration. So that means a vector. If you want to find the magnitude of the acceleration at time t equal 4, then take square root of 24 square plus 6 square. That will give the direction of the magnitude of the acceleration at t equal 4. If you want to find the direction of the acceleration at that instant, tan inverse 6 over 24. You can find it. But they are not asking that. They are just asking to find the acceleration in terms of unit vectors. Yeah. Okay, B part. This is the A part. Yeah, A part. B part. At time capital T seconds, where t greater than or equal to 0, P is moving in the direction of 2I plus j. So they are giving the directional vector at that time. So B part, they are saying at time t equals 0, P is moving in the direction of 2I plus j. Moving in the direction. Moving means something related to velocity. So by using the velocity vector, we can find its direction. Yes, tan inverse this over this. Yeah, tan inverse t squared minus 2t plus 2 over 3t squared minus 8 is the direction, right? But they are giving the directional vector, which is 2I plus j. Okay, so at time t, capital T. So B part, I'll write it here. So at time t, we can say at time t equal t, the velocity vector could be given as 3 capital T squared, 3t squared minus 8I plus t squared minus 2t, t squared minus 2t plus 2j, unit vector j. Okay, so the direction of this vector, velocity vector, we can find by using this one. Tan theta is equal to t squared minus 2t plus 2 over 3t squared minus 8. But at the same time, they are telling the directional vector of the velocity is given, vector of velocity is given as 2I plus j. So from this, tan theta is equal to 1 over 2. This j means 1 over 2. So both are the same direction. So therefore, t squared minus 2t plus 2 over 3t squared minus 8 should be equal to 1 over 2. Right, now solve it. you'll get a quadratic equation. So cross multiply 2t squared minus 4t plus 4 is equal to 3t squared minus 8. So rearrange it into a quadratic, standard quadratic format. So t squared plus 4t minus 12 equals 0. Factorize it. Before that 4t should be given as 60, sorry. 60 minus 2t minus 12 equals 0. You can continue it. So that will become t plus 6, t minus 2 equals 0. Therefore, t equal minus 6. The solutions are minus 6 and t equal to, but time cannot be negative. So it must be a positive quantity. So therefore, time t is equal to 2 seconds. So this is not an acceptable answer because it's a negative value. Time cannot be negative. So that's the final answer, 2 seconds. Okay, question number 2 based on momentum. You know that you are doing from even IGCSE, the law of conservation momentum, you are familiar with that. But how to use the Newton's law experimental results related to momentum, that is, it says that speed of separation equal to E times speed of approach. So speed of separation is equal to E times speed of approach, where E is coefficient of restitution. It's experimentally found. It's speed, nothing velocity. We don't consider velocity. But here when we say speed, that is relative speed. For example, how to use this equation. For example, first example I can say, if there's a particle A moving at u1, there's another particle B which is moving at u2. This is before collision. So here if A wants to collide with B, u1 must be greater than u2. So the relative speed, that means compared to B, the speed of A should be u1 minus u2. That's a difference. That's the relative speed. So the speed of approach is u1 minus u2. The relative speed we need to consider. So after collision, if they move like this, A moves in the same direction v1, B moves at v2 in the same direction. Here speed of separation, that means after collision we take they are not colliding again. So if they are not colliding again, v2 must be greater than v1. So at what speed they are separated means every 1 second this will move v2, that must be greater than distance moved by this every second v1. So the speed at which how much they are going to separate every second is v2 minus v1. So here how do we write the this equation, the experimental results equation, Newton's experimental results related to impact? How do we write? Speed of separation is v2 minus v1 must be equal to E into speed of approach. They are relative, that is u1 minus u2. u1 must be greater than u2. Okay, second example we can write like this. A particle A is moving this direction at u1. Particle B is moving towards A at u2. After collision, A and B moving in the same direction, v1, B moving in the same direction, v2. So here's speed of separation, v2 must be greater than v1, then only they'll separate. So that means here v2 minus v1 is equal to E times speed of approach. So imagine if the B thinks that B is at rest, A will approach towards B relatively at u1 plus u2. E times u1 plus u2. Okay, third example. A is moving towards B at u1. B is moving towards A at u2. After collision, they are bouncing off. A is moving at v1. B is moving away at v2. So here, at what speed they are separating from each other every second. This will move a distance v2, this will move a distance v1, so the separation will increase by v1 plus v2 during every second. That is the relative speed. So here we will write v1 plus v2 equal e into speed of approach, same as this one, e into u1 plus u2. After collision, if they join together, entangle together and move, we take E equals 0. So there we don't write this equation. If they entangle, E becomes 0. So we don't consider. This restitution, we take it 0. So we don't consider that equation there. Okay, question number 2, this diagram is given. The point A lies on a smooth horizontal flow between two fixed smooth parallel vertical walls Wx and Yz as shown in the plan view. The distance between Wx and Yz is 3d. The distance from A, distance of A, so there's a point A. Distance of A from Yz, this is d, the distance is d. A particle is projected from A, along the flow with a speed u, the initial speed u, with a speed u towards Yz in the direction perpendicular to Yz. The coefficient of restitution between the particle and each wall is 2 by 3. So they are giving E is equal to 2 by 3. Okay. The time taken for the particle to move from A, bounce off each wall once and return to A. So that means A is moving from here, hitting the wall YZ, bouncing off, then moving towards wall WX. They are bouncing off and returning to the same initial point A. So the total time taken for that motion from here to here, here to here, here to here is capital T1. Find T1 in terms of D and U. Okay, nothing. It's a speed equal distance over time, and we need to find the speed after collision. First time when it collides here, second time when it collides here, by using the speed of separation is equal E into speed of approach. The Newton's experimental results related to impact we had to use and find the speeds after collision from YZ and after collision from Wx. Right, okay, so we'll do that. So we know speed equal distance over time. So we'll take, there are 3 sets of motion. 3 sets of motion means first set from A to YZ. Then after collision, it's bouncing off. We'll find the speed, at what speed will it bounce off. So with that speed, it will travel from YZ to Wx. Then it will move from there, it's going to bounce off again. The coefficient of restitution is 2 by 3. We can calculate the speed after collision. Then with that speed it will move from here to A. So there are 3 sets of motion. We will say the time taken to move from A to YZ T1, YZ to WX T2, then WX to A T3, T1 plus T2 plus T3 equal to capital T1. We will find the capital T1. Okay, so when it moves for the motion from A to YZ. So we know that speed u is equal to distance d over t1. So t1 is equal to d over u. So that is first equation. Okay, that is the first time we found it. After collision, what will be the speed? So we are using the equation speed of separation is equal to E times speed of approach. So speed of separation, this is rest anyway, it's a wall, it won't move. So relative to this, it's going to bounce off at a speed v1 minus 0 because yz is at rest. So relative to the wall, it will bounce off at a speed v1, that's a speed of separation. v1 is equal to E times speed of approach. It's moving towards at a speed u, E u. So v1 is equal to EU after collision. So with this speed, it's going to move from yz to wx. So we'll consider for the motion from yz to, they are naming that yz, is it yz to, yz to wx. Right. So constant speed. After collision, it bounces off at this speed. Then it move at constant speed because no friction. So speed equal distance over time. Time equal distance over speed. I can use this one. So T2 is equal to, the distance is going to move from here to here is 3D. 3D over time taken, that is, the speed, that is going to be EU. Let it be second equation. Is it? Okay. Now what will be the speed? So it's going to approach Wx with a speed EU, that is V1. What will be the speed after collision from Ws? That speed after collision from them means, if I say speed of speed of separation, because the wall is at rest, the speed at which is bouncing off relative to Wx is V2. That is equal to E times speed of approach. It's approaching the Wx with V1. V1 means EV1, that is E times EU, that is E squared U. That is the V2. We'll substitute the values of E squared later. It's given. E is given as 2 by 3. Okay, so it has to travel from Wx to A. So for the motion, from Wx to A, right? So it will move a distance 2d. So that time T3 is going to be, the distance moved is 2d divided by the speed E squared U. Okay, the total time T1 is equal to T1 plus T2 plus T3. So we know T1 is d over U. T2 3d over EU plus T3 2d over E square U. Okay, so substitute the values of E. E we know 2 by 3. Substitute the values and we know that E is equal to 2 by 3. Substitute and solve it. Just simple algebra. You will get 10d over U. That's the T1. Okay, so here you have to substitute 2 by 3 for this E, you get this final answer, right? Okay, that's not an issue. B part, just one mark. The ball returns to A for the first time. So after this collision, when it comes to A, the time taken this much. You see, we found it. The ball returns to A for the first time after bouncing off each wall once. The further time taken for the particle to move from A. So now it's approaching A after these collisions, what I explained. Now it's approaching A. At what speed is it approaching? It's going to approach at V2, E squared U. Now earlier it started the motion initially with U. Now it's going to approach A with E squared U. Right. Now what's going to happen? The ball returns to A for the first time after bouncing off each wall once. The further time taken for the particle to move from A, bounce off each wall. Now again it's going to bounce off each wall and return once and return to A for the second time T2, capital T2. Find T2 in terms of D and U. Okay, so the same thing, if you want, you can do the same thing. Now E squared U, you can find the T1 again. The distance is going to move is D. After collision, it will be E cube U. It will move from here to here. After collision here, the speed will be E to the power 4U. Like that you can do again, but it is just one mark. So we will find in a technical way, what is it? Simply you can see that T1 is equal to 10D over U, where U was the initial speed. Now I put it E squared U, but earlier it left with first time with a U, the speed U. When it moves with initial speed U and return A after each one collision with the two walls, the time taken is 10D over U. Now it's going to approach YC with a speed of E squared U. So this time T2 could be, T2 is equal to 10D over, instead of U put E squared U, because that's the initial speed, starting speed. Now for the second set of motion, starting speed is E squared U because it's moving from here to A, then continuing the motion. So E squared U, that is 10d over e squared means e equal to 2 by 3. So 4 over 9 u. So it's going to be 90 over 4. That is 45 d over 2u. That's the answer for B part. Okay, question number 3. A particle P of mass 0.5 kilogram is moving with velocity lambda I plus j meter per second with when P receives an impulse of magnitude square root of 5 by 2 Newton second. Immediately after receives the impulse, the P velocity becomes 4I meter per second. Given that lambda is a constant, find two possible values of lambda. So we can do this in two different ways. One, the first method, just by using I equal mv minus mu and solving it. Second method, by using a vector diagram. Okay, I'll do both methods. We know that impulse I is equal to, question number 3, I is equal to mv minus mu, where I, v, u, they are vectors. So method 1 I am doing it. So this is the method 1. Okay, we know the impulse is given, that magnitude is given square root of 5 by 2 Newton second. Okay, we'll find the impulse in terms of vectors. We can call impulse vector, yeah, by using the given initial and final velocity. The final velocity after collision is 4I. So it's given that P is equal to 4I after collision. Before collision, the velocity is lambda I plus j, they are the unit vectors, or lambda I plus lambda j, that is the initial velocity before collision. Okay, we will substitute this here. So impulse is going to be, it's a vector, mass is given, which is 0.5 into v, v is 4I, minus 0.5 into u, that is lambda I plus j. We'll solve it. Nothing. So it's going to be 2I minus, this is half, is it? 0.5 lambda I minus 0.5 lambda j. So that's going to be 2 minus 0.5 lambda I, sorry, 2 minus 0.5 lambda I minus or plus minus 0.5 lambda j, right? Or you can put a minus here, no problem, that's not an issue. Okay, so this is the impulse vector, but we know the magnitude. I told that more when I am starting this first question. If you know the vector, for example, vector, say for example, vector r is equal to ai plus bj. The magnitude is given by square root of a squared plus b squared. The direction tan inverse b over a. So we'll follow that basic principle regarding how to find the magnitude. So we know the magnitude of I, the impulse is given, which is square root of 5 by 2 Newton second. Newton second, yeah, unit I am not putting it. So that is equal to square root of 2 minus 0.5 lambda all things squared plus 0.5 lambda all things squared. Because this squared, that is a squared plus b squared, square root of it. So this squared plus this squared. Okay, so we'll solve it. So 0.5 lambda easy to handle with fractions, so we can put half lambda. So it's going to be square root of a minus b all things squared, that format. So it's going to be 4 plus 0.5 means I can write half, that is lambda squared by 4, 2ab minus 2ab means 4 into half, that is 2 lambda, plus here half lambda all things squared means lambda squared by 4. Okay, so Both sides square root are there. Take the both sides better the square because to remove the square root. So it's going to be 5 by 2 is equal to, here lambda squared by 4, lambda squared by 4, it's going to be lambda squared by 2 minus 2 lambda plus 4. Okay, so better multiply the whole equation by 2. So you will get to solve it. Just you take it to solve it and get the quadratic equation. So when you multiply the whole equation by 2, you will get lambda squared minus 4 lambda 8. Here 5, when it goes, it will become plus 3, is it? So it's finally you will get lambda squared. So lambda squared, rearrange it, lambda squared minus 4 lambda, multiply the whole equation by 2, lambda squared minus 4 lambda, here 8, here 5, 8 minus 5 plus 3 equal to 0. Okay, it's easily we can factorize it, lambda squared minus 3 lambda minus lambda plus 3 equals 0. So lambda into lambda minus 3 minus lambda minus 3 equals 0. So that is lambda minus 3, lambda minus 1 equals 0. So the values of lambda equal to 3 and lambda equal 1. Okay, so that's the final answer. They have to find the lambda, two values. Okay, method 2. In method 2, we are going to draw vector diagram according to vector addition rule. So before that, you should know certain things related to vector addition rule. The second vector should be drawn from the end of the first vector. Third vector should be drawn from the end of the second vector and so on. Then you should connect the most initial point of the first vector and the last point of the last vector. If you connect the line, that length of the line indicates the magnitude of the resultant vector, and the direction of that line what you draw connecting the first point of the initial vector and the last point of the final vector, that line indicates the resultant direction of the resultant vector. Okay, for example, if it is given like that, you know, the direction of I is taken towards right, you know, the unit vector, direction of j is along the direction of y, you know that. Minus I means towards left, minus j means towards down, is it? You know these things. For example, if a vector A is given by minus 4i plus 3i, 3j. Okay, how to show that on a diagram? So what is this? How to find this vector? Minus 4i. So on towards left 4 units along the minus I direction. 3j upwards, because j is upwards positive, 3j, this is this direction, positive 3. So vector A is this one. This is the vector A. This is the direction of vector A. What will be this angle? You can use tan inverse 3 by 4. If you find it, you will get the direction angle of the vector A. Or if they give vector B is equal to minus 2i minus 4i. If it is given, 4j. If it is given like that, minus 2i minus 4j if it is given. Okay, vector B, how to show that? Minus 2i towards left 2 units, minus 4j downwards 4 units. If you connect most initial point and the final point, that will be the vector B. That will be the vector B. So if you draw according to scale, just measure it. Or if you are just sketching, use the Pythagoras theorem to find the magnitude of the vector B. The angle you can find by using tan inverse 4 by 2. Okay, so these things you must know when we are drawing the vector diagram. Vector addition rule, there is nothing called vector subtraction rule, vector addition rule. So even if you get something like vector R is equal to vector A minus vector B, means that is vector A plus minus vector B. That's the meaning of vector addition rule. So remember that. Okay, we'll come to the diagram now. Okay, so we are going to use vector addition rule. So impulse is defined as I equal delta mv, change in momentum. That could be written as I equal mv plus m minus u. We can write that way, is it? No problem, because as a vector addition rule. So here the vector addition is done between two vectors. What are they? MV and minus MU are the two vectors added to get the impulse vector. Okay, so there MV, what is it? MV, mass into V. So the mass is given 0.5 kilograms. So MV is equal to 0.5 into 4I. So that is 2I. So that could be shown MV could be shown along I direction as a 2 unit. That is MV. Right. Now with that minus MU is added. Okay. Vector U is given as lambda I plus j. So vector U is given as lambda I plus j, that is lambda I plus lambda j. Mu is given as m lambda I plus m lambda j. Minus mu means m lambda minus I plus m lambda minus j. Okay, how can you show this minus mu in a vector diagram? M lambda is the magnitude in direction of I, so minus I direction m lambda plus minus j direction, that is downwards m lambda. So vector minus mu is this one. This is the vector mu minus mu. Vector minus mu is this one. What will be this angle? This angle with the I direction or with the negative I direction. What will be this angle? Theta. That is tan theta is equal to m lambda opposite to adjacent. That is going to be 1. That means theta equal 45 degree. So that's the direction of minus mu. Okay, so we found the actual directions of the two vectors. Those are added to get the vector impulse. That is mv and m minus u. That is m minus u, we got it now. So if we consider all these together now, so this is the direction, you know, minus mu means that is along this direction. That makes an angle 45 degree. Okay, so we'll draw now mv. This is mv is towards right, which has unit 2. mu is at an angle 45 degree with this one. Is it 45 degree? This is mu. Okay, what will be its magnitude? So magnitude of minus mu, we don't need to consider minus when we consider the magnitude. The magnitude of mu, how much is it? M lambda square root of m lambda all things squared plus m lambda all things squared. Yeah, so that's going to be m how much? We know that 0.5 lambda all things squared plus 0.5 lambda all things squared square root. That's going to be the magnitude of mu. Okay, so 0.5 means half, is it? So it's going to be, so that we can just sketching it. So magnitude of mu is going to be half lambda all things squared, half lambda all things squared plus half lambda all things squared, its square root. So that's going to be lambda squared by 4 plus lambda squared by 4 square root. That is 2 lambda squared over 4, that is lambda squared by 2. So that's going to be lambda over root 2. Lambda over root 2 is the magnitude of mu. So now this is lambda over root 2. That's the length of this line or the magnitude of vector mu. So this magnitude mv, the vector mv is 2. Magnitude of mu is lambda over root 2. Okay, now accord vector addition rule. This is the first point of the first vector mv. This is the final point of the second vector. If I connect these 2 points, initial point and the final point, if I connect it, we will get the resultant vector. That's not 90 degree, looks like 90. So something like, if I connect these 2 points, This is the impulse vector. I need to find this magnitude. We know that this magnitude lambda over root 2, this magnitude 2. Now I have to find the value of lambda. Right, so how can I find it? This vector, this length, magnitude of I, we know that that's given as square root of 5 over root 2. So this magnitude is equal to square root of 5 over root 2. Square root of 5 by 2, that is the impulse vector. Okay, so now I need to find the value of lambda. So for this triangle, I know this length, square root of 5 by 2, that is the magnitude of impulse. I know this length, that is MV2. I know this length, that is MU, which magnitude is lambda over root 2. Yes, I need to find the lambda. How can I find it? Now we can use cosine rule for this triangle. Use the cosine rule for this triangle. So this square is equal to a square is equal to b square plus c square minus 2bc cos 45. Solve it. You will get the lambda in a quadratic equation. Like the same quadratic equation, you will get it again. Okay, I drew the diagram again, little bigger. Now we can use the cosine rule, that is AC squared is equal to AB squared plus BC squared minus 2AB BC cos 45. Okay, AC squared, root 5 by 2 squared, that is 5 by 2, is it root 5 by 2, all things squared, 5 by 2. AB squared, 2 squared, that is 4. BC squared, that is lambda over root 2, that means lambda squared by 2 minus 2 AB, that is 2 BC lambda over root 2 cos 45. You know that cos 45 1 over root 2. Right, we'll solve it. So here root 2 into root 2 will be 2. 2 and 2 will get cancelled. So we'll solve 5 by 2 equal 4 plus lambda squared by 2 minus 2 will get cancelled, minus 2 lambda. Multiply the whole equation by 2. 5 is equal to 8 plus lambda squared minus 4 lambda. That is lambda squared minus 4 lambda plus 3 equals 0. Exactly the same quadratic equation we got in the first method. Here I am getting again. So factorize it. You know I already did that. So when you factorize it, become lambda minus 3 times lambda minus 1 equals 0. So lambda equal 3 and lambda equal 1. These are the solutions. Okay, same answer we are getting it, but different methods. Question number 4. A truck of mass 900 kg is moving along a straight horizontal road with the engine of the truck working at a constant rate of P watts. So output power is P watts. The resistance to the motion of the truck is modeled as a constant force of magnitude R. That's a resistive force. At the instant when the speed of the truck is 15 meter per second, the deceleration of the truck is 0.2 meter per second square. So we'll put that in a diagram, easy to understand. So we'll put it on a diagram. So if I put it on a diagram, this is the truck. So it's moving, I'll take it towards right at a speed of 15 meter per second. So its mass is 900 kilogram. The power output is P and there's a resistive force R. There's a resistive force R when it is moving at a speed of 15 meter per second. And the deceleration is, they are telling the deceleration, not acceleration. Deceleration means acceleration opposite to the direction of motion. So I took velocity towards right, that is motion towards right, means acceleration should be opposite to that direction, means towards left. So the acceleration is towards left. So I can show it like this. Towards left, I can show acceleration towards left A equal 0.2 meter per second square I can show. Or I can show towards right, the same direction as this, equal to minus 0.2 meter per second square. Either way I can put it on the diagram. I put it like this direction. The direction of velocity A equal minus 0.2 meter per second. So that's the meaning of deceleration. Okay. Then they are saying later same truck is moving down a straight road inclined at an angle theta to the horizontal where sine theta is 1 over 30. So if they give sine theta 1 over 30, we can find cosine and tan by using a right angle triangle. The resistance to the motion of the truck is again modeled as constant force of magnitude R. So same as earlier, the same resistive force is acting. The engine of the truck is again working at P. So the power is same P now also. At the instant when the speed of the truck is 12 meter per second, the acceleration. So here the acceleration, the word used means along the direction of motion, acceleration is positive quantity, which is 0.4 meter per second square. So I can show that this statement, all these statements on the second diagram on an inclined plane. So it's like this. So it's at an angle theta. The truck is moving along the along the inclined plane upwards. So the speed is, at a speed is 12 meter per second. Same truck. The power is P. Acceleration is given 0.4. So along the direction of motion, acceleration is 0.4 meter per second squared. Along the same direction of motion. The mass is the same, 900 kilogram. And they are saying sine theta 1 over 30. So we can find cosine or whatever it is if we want. Okay, so resistive force is the same. So it's moving up, one minute, truck moving down. Sorry, I made a mistake. Truck is moving down, right? So downwards, not upwards. So downwards. So the velocity is along the plane down, which is 12 meter per second. Acceleration, the same direction. So the acceleration also down, that is 0.4 meter per second squared. So resistive force opposite to the motion, same magnitude. The power is the same, P. They are saying the power is the same, P. Yes, right. And also we know that sine theta 1 over 30. So if you want, we can find cosine, but we'll see. Okay, so these are the two information given regarding motion on a horizontal flow part and motion on a bank track or inclined plane downward direction. So the thing we are going to use Newton's second law, F equal ma, but we need to find the forward thrust because of the power. Power, there will be one more force, that is the forward thrust. I didn't show that. So power means, you know that power work done is equal to, so engine is working, engine is on. So engine is on means it's going to give a forward thrust. So forward thrust, how to relate? We know that work is equal to force into distance moved. But if you divide the work done by the engine, is it work done by the engine? So when you divide the work done by the engine, divide T, it's going to be force into speed. So this is power equal FV. So there is a force due to the power output of the engine. That's going to be the forward thrust. So I'll put that FT, forward thrust FT. So here also there will be forward thrust along the direction of motion FT. Okay, so FT will be the same because power output is the same. So FT will be the same. Okay, so when it moving on a horizontal plane, when it moves on horizontal plane, along the direction of motion, I'm going to use F equal FA. So we know that FT is equal to P over V, FT is equal to P over V. So F, the resultant force, that is FT minus R is equal to MA. Ft. These are the only two forces acting when it is moving on a horizontal flow, forward thrust and the resistive force. But we know that Ft is equal to P over A. So I can write that also here, but P equal FTV. Therefore, Ft equal P over V. So therefore, means of Ft, I can say P over V minus R is equal to Ma. We know the values. We know the values of speed. We know that mass. We know that acceleration. We know that. So we are writing this along the direction of motion, is it? So P over V is 15 minus R is equal to mass is 900. Along the direction of motion I am using it, so minus 0.2. Okay, so solve it and get an equation. You will get P minus 15R. P minus 15R is equal to minus 2700. Let it be first equation. Okay, this is for the motion on a horizontal plane. Okay, we can use the same type of equation when it moves on a slope, when it moves on an inclined plane. So I can write when it moves down on the inclined plane. So along the plane down I am using it. F equal Ma. What are the forces acting on it? Ft plus the component of the weight also acting along the plane down. I didn't show it on the diagram, but that also will act along the plane down. That is mg sine theta. So when on an inclined plane, if you keep an object, if the angle is theta, the weight is acting vertically down mg. This angle is 90 minus theta. The component of the weight along the plane down is mg cos 90 minus theta, that is mg sine theta. So there is mg sine theta also acting along the plane down. So that is Ft plus mg sine. I put this only the information given in the question, right? I didn't put this mg sine theta there because I just drew the diagram to show the data, what is given there. They didn't tell anything about the mg sine theta. So anyway, we had to put that in the question. So forward thrust is there, mg sine theta is there. Mg sine theta is the component of the weight along the plane down minus R equal to Ma. Okay, Ft, same way I can write again. Ft I can say P over, we know that P over V, is it Ft is equal to P over V plus mg sine theta minus R equal Ma. P over V, now the speed is 12 meter per second. Earlier it was 15 meter per second, now it's 12 meter per second. So we'll continue the same thing. So P over 15 plus mg, that is m is 900 into 9.8 sine theta. Sine theta is given 1 over 30. Sine theta 1 over 30 minus R equal Ma 900 into, this is acceleration along the plane down 0.4. Okay, solve it and again get an equation in terms of P and R. You will get P minus 12R is equal to here, P minus, here we got first equation, P minus, earlier the speed was 15, so P minus 15R, we got it. Now here we'll get P minus 12R is equal to 792 second equation. 792, that's a second equation. So a simultaneous equation we are getting it. So P minus 15R equal minus 2700 is the first equation. I already got it. That equation I already got it. Okay, solve it. You can use by using calculator, or you can use just subtract 2 minus 1. Either way, anyway, it's up to you. Solve it. You need to find the R. That's a question. No, they ask to find the value of R. So you just solve it. You can solve Yeah, 2 minus 1. Or you can use the calculator, but not necessary calculator. 2 minus 1 means 12 minus 15R means, yeah, 12 sorry, 12R minus 15R is equal to 792 minus 2R1000. So, okay, so that will be 3R is equal to, yeah, minus 12. So here minus 12R, yes. 2 minus 1 means 2, that's minus 12. So that minus 12R minus 9, yeah. So 3R is going to be, 3R is equal to 3492. So R equal 1164 is the actual answer, but you can give it in 3 SF. So 1160 Newton, or 2 SF means 1200, but normally you can give it in 3 SF, 1160 Newton. That's the answer. Okay, question number 5. This diagram is given. A uniform rod AB has length 4 meter. So uniform rod means the mass will act at the center of the rod at 2 meters from A. Weight is 50 Newton. So the weight will act 2 Newton from A. The rod has its end A on a rough horizontal floor. The rod is held in equilibrium at an angle alpha to the ground by light inextensible string, inextensible cable attached to the rod B as shown in figure 2. The cable and the rod lie in the same vertical plane and the cable is perpendicular. So the cable perpendicular to the rod. Tension in the cable is T newtons. Alpha, sine alpha 3 by 5. Show that T equal 20. Okay, so T equal 20. So there will be a force at A where it touches the ground. There will be a friction and normal reaction. But the question is just to find T. They are giving just 3 marks. So it's better take moment about A. We'll think about the forces acting on the rod. So the weight will act at its center. So the weight will act at the 2 meters from A vertically downwards. That is 50 Newton. So we can take moment about A. So when we take moment about A, you know the definition of moment: force into perpendicular distance to the line of action of force. So this is the line of action of force, 50 Newton. If I take moment from A, about A, perpendicular distance to this line is this length. That is, I can name this as AB. If I say this is C, the perpendicular distance to the line of action of weight is AC. Is it? Same way, for the tension, the perpendicular distance from A is the length of the rod, because this tension is perpendicular to the rod. Force into perpendicular distance to the line of action of force from the pivot is defined as the moment. So we'll take moment about A. So we know that sine alpha is given. Sine alpha is given as 3 by 5. So if you think about right angle triangle, cos alpha will be equal to 4 over 5. Okay, take moment about A. I'm answering A part. About A. So the only two forces acting on it is the weight at the center of mass, which is 2 meters from A, and the tension. Those are the only two forces acting on the rod AB. So clockwise moment is 50 times the distance AC, perpendicular distance to the line of action of 50 is AC, minus, we'll take moment about A, we'll take clockwise direction positive. So 50 into AC minus T into A, I can name this D, AD equal to 0 because it's at rest, it's at equilibrium. Okay, so 50 into AC. AC is, this is center of mass, we normally denote by capital G. AG is 2. 2 in this right angle triangle, 2 cos alpha is AC. But we know that AC equal, in the right angle triangle AGC, AC equal 2 cos alpha. So 50 into 2 cos alpha minus T into AD is 4 equals 0. So cos alpha we know 4 by 5. So take the right, 40 is equal to, make the 40 subject, 50 into 2 into cos alpha 4 by 5. Solve it and find the T. You will get 20 Newton. That's A part. Okay, that's the answer for the A part. Take moment about A. There are forces acting on A, but I took moment about A, so those forces won't included in my moment equation because distance from A to A is 0. So those forces won't included in my equation. That's the advantage. If you take moment about a point where there are a lot of unknown forces, those forces won't be included in your calculation. So you can avoid those unknown forces in your equation. So easy to reduce the unknown quantities in the equation. Okay, so now B part. Given also that the rod is in limiting equilibrium, find the value of coefficient of friction between the rod and the ground. So now the thing is, when the rod is touching the point A, it will try to slip to the left. It will try to slip to the left. Is it? If it will try to slip to the left, if you try keep it like this, it will try to slip to the left. So the friction will be acting towards right. So B part, if I draw the forces acting on the rod AB again, the tension is acting there already. The same tension will act, which is 20 Newton. This is 90 degree. At the point A, there will be a friction this direction, F equal mu R, because it's at limiting friction, and there will be normal reaction R, and there will be weight acting on it. And the weight will act at the center. These are the forces acting on the rod. AD, I name it AD, I think that rod AB, sorry, this is B. Rod AB. These are the forces acting on the rod. This is the center of mass, I name it G. AG 2 meters, GB 2 meters because it's a uniform rod. Okay, so this angle is alpha. This angle alpha. Okay, so if this is alpha, this also alpha, is it? Alternative angle. This also alpha. This also alpha. So this will be 90 minus alpha. Okay, so these are the only forces acting. 1, 2, 3, 4 forces acting on the rod AB. So, and the rod is in limiting equilibrium, means the resultant force in any direction must be equal to 0. So, we'll resolve all the given forces horizontally and vertically. So, that's the easy way in here. So, we'll resolve it vertically. R minus mg, we know the mg is given, mass is given. Yeah, R minus mg, R minus mg, because mg is downwards. This is horizontal force, has no vertical component. This 20 is at an angle 90 minus alpha with horizontal tension. The tension 20 Newton what we found is at an angle 90 minus alpha with horizontal line. So that is plus 20 sine 90 minus alpha equal to 0. Okay, so R minus mg is 50. Yes, mg is 50 plus 20 sine 90 minus alpha cos alpha, sine 90 minus alpha cos alpha 4 by 5 equals 0. Find the R. You will get 50, take to the right, 50 minus 16, that is 34 Newton. Here 4 by 5 because cos alpha, sine 90 minus alpha cos alpha 4 by 5. So R is equal to 34 Newton. Yes. Now when you resolve horizontally, how many forces are acting in horizontal direction? This is vertical force, won't have any horizontal component. Vertical force won't have any horizontal component. You know that you can't resolve a vector through 90 degree. So mu R and this one minus 20 cos 90 minus alpha equal to 0. Cos 90 minus alpha sin alpha. Fr equal mu r. Fr equal mu r because it's at limiting equilibrium. So that's what I put Fr equal mu r. So mu into R3 or 34 equal to, take it to the right, 20 sin alpha 3 by 5. Okay, solve it and find the mu. You will get 12 by 34. That is 6 by 7. Mu is equal to 6 over 17. That's answer. That's the value of mu. Coefficient of friction. Okay, question number 6. Two particles P and Q are moving in opposite directions along the same straight line on a smooth horizontal surface so that the particles collide directly, head-on collision. The mass of P is K times M and the mass of Q is M. Immediately before collision, the speed of P is X and the speed of Q is Y. So we'll put that on a direction. So there are two particles. This is P moving at X. Its mass is Km. This is particle Y. Sorry, Q. It's moving at speed Y. Its mass is M. This is before collision. B dot C dot for before collision. Okay, immediately after collision, P and Q are moving in the same direction. The speed of P is V and the speed of Q is 2V. So speed of Q is 2V. And speed of P is V. So mass is Km. This is M. This is after collision. Okay. The coefficient of restitution between P and Q is 1 over 5. So E equal 1 over 5 given. The magnitude of the impulse received by Q in the collision is 5 MV. Whatever it is, both will receive the same impulse according to Newton's second law, also Newton's third law also. Whatever the force exerted by P on Q is equal to same as the force exerted by Q on P. So both will experience the same force for the same time until they are in contact during collision. So Ft will be the same on both particles. I equal Ft. So the impulse exerted by P on Q is same as impulse exerted by Q on P, but they will be in opposite direction, same magnitude. So impulse, so I'll just put generally I don't want to say which particle experience that one. Both will have the same magnitude of impulse, that is 5 MV. But remember that during collision, if you draw the diagram during collision if you draw it, so P is this one, I enlarge diagram, this is Q. P will exert force on Q this direction, Q will exert force on P this direction. So I told that Ft is equal to I. So impulse on P is towards left, impulse on P is towards left because same as the direction of force and the impulse are the same. During collision, according to my diagram, P will experience force towards left according to my diagram. So P will have impulse towards right, Q will have impulse towards P will have impulse towards left and Q will have impulse towards right. So anyway, I is equal to 5 ME, that is the magnitude of the impulse they are telling it. Okay, so A part, there are 3 parts. Find Y in terms of V. So we can use first part. So we know that whatever the particle experience the same impulse, we need to find the Y related to particle Q, is it? So we'll use I equal mv minus mu for the particle Q. So we can say for particle Q, for the Q, I is equal to delta mv or mv minus mu or delta mv, you write Okay, so finally, so Q will experience impulse according to my diagram. So Q will experience impulse towards left. So I have to use it towards left. So towards left, 5 mv is equal to, we know that mv minus mu, that's a general equation. Mv minus mu, general equation. Don't compare these two v, those things. I general equation, I wrote it. Mv minus mu. For Q, I am writing it. So for Q, the impulse should be towards left. I already explained when I do here. That is towards left. So the final velocity for Q is to the towards right. So final velocity, sorry, I made a mistake. Q will experience going to towards right. So not left, towards right. Sorry. Q will experience the impulse towards right. So 5 mv. The velocity of that after collision is 2v. So its mass is m. m into 2v minus m into initial velocity for Q is towards left. I am using towards right, so that is minus 5. So solve it. So all the m will get cancelled. So 5v is equal to 2v plus y. So y is going to be 3v. That's the answer. They asked to find the value of y in terms of v. So y is equal to 3v. Okay, so if I try to write the same thing for particle P, I will be in trouble because I will get the same format, so I won't get any equation. So for second answer, we x in terms of v they are asking. So we'll use that Newton's experimental results for collision, that is, which includes E. Okay, so what it says, I already explained that in the question 2. That is relative speed of separation is equal to E times speed of approach. That's the relative speed of approach. So speed of separation is equal to 2v minus v. 2v minus v is the speed of separation, that is after collision, is equal to E into speed of approach. They are moving in opposite direction, x plus y. So that is 2v minus v is equal to v. We know E, that is 1 over 5 into x we need to find, y is 3v. Okay, solve it. So 5v minus 3v, x is equal to 2v. So now students ask to find x, can't I use the same thing for p? What will happen if you use the same equation, change in momentum, I is equal to delta v? For p, what will be in trouble? P will be in trouble because there will be k also in your answer, but k is an unknown. That's the third part. That is the third part. So that's the reason I used this equation. That is the experimental results of collision during collision, the experimental equation. Because if I try to use the same format, I equal delta mv for p, the equation will include k also. K is an unknown, so k and x will be there in that equation. So that's the reason, to avoid it, I use this equation to find the x. Now third part, they ask to find the k. Now if you want, you can use the same equation for p, same equation for p. There will be k, but we know x and y, so you can solve it. Or you can use law of conservation of momentum. Either way you can approach law of conservation of momentum. You can use, or I equal mv minus mu for particle p. You will be able to find the value of k. Okay, so I'll use the law of conservation momentum. If you want, you can use I equal mv minus mu for particle p. You will end up with the same result. So I'll use the law of conservation just for law of conservation of momentum. That is k, I'm using it towards right, km into x minus m into y, because opposite direction, m into y is equal to km into v plus m into 2v. Okay, so here you can substitute x and y values, and all the m will get cancelled. So k into x, we can say 2v minus y is 3v, is it? All the m's got cancelled, is equal to k into v plus 2v. Okay, so what will it be? 5v. So it's going to be, yes, if you take it to the left, you will get, check it. Yeah, so here 2kv, all the v get cancelled, v will get cancelled. 2k minus k is equal to k, 3 plus 2, 5. The value of k is 5. If you want, you can use same thing, I equal mv minus mu. For p, you will find the k. That we also try, you will get the same answer, k equal 5. Nothing go wrong. Okay, now B part of question number 6. Find in terms of M and V the total kinetic energy lost in the collision between P and Q. So nothing, find the initial kinetic energy. So kinetic energy loss means initial kinetic energy minus initial total kinetic energy minus final total kinetic energy. That's all. So initial total kinetic energy equal to half km x squared plus half m y squared. Substitute half, we know the k 5, 5m x squared. X we found it as 2, so 2v means 4v squared, 2v all things squared, 4v squared plus half m, y is 9v, 3v, so that is 9v squared. Solve, it's going to be 20 divided by 2, 10v squared, 10mv squared plus 4.5 mv squared. So initial total kinetic energy 14.5 mv squared. Okay, so then final total kinetic energy half km v squared plus half m 2v squared. So that's going to be k is 5. So 5m v squared half into 5m v squared plus 4m v squared by 2, 2m v squared. So it's going to be 2.5 to 4.5 m v squared. Kinetic energy is a scalar quantity. Even if they move in opposite direction, we don't put minus sign. Careful, students make mistake. Even they are moving in opposite direction, energy is a scalar quantity, has no direction. Even if there are two particles moving in different direction at an angle alpha v, at an angle beta v, v1 v2, if the mass is m1 m2, the total kinetic energy half m1 v1 squared plus half m2 v2 squared. We don't consider direction because energy is a scalar quantity, so we don't consider the direction. It's just a value, numerical value. Okay, so 4.5 mv squared. So kinetic energy lost, that's the question. So kinetic energy lost during collision. Initial kinetic energy 14.5 mv squared minus 4.5 mv squared, that is 10 mv squared. That's answer. Okay, question number 7. This diagram is given. This is related to center of mass. We know that when we are finding the center of mass, we use the standard equation sigma mi xi over sigma mi is the center of mass x bar. So for example, in a Cartesian coordinate, if you want to find the x coordinate of the particles, like there is a particle m1 at a distance x1, there is a particle m2 at a distance x2, and a particle m3 at a distance x3, then the center of mass of these three particles m1, m2 and m3, we can use this format sigma mi xi, that is m1 x1 plus m2 x2 plus m3 x3 over sigma m, that is m1 plus m2 plus m3 is the x coordinate of the center of mass. That means x coordinate of the center of mass means that is the distance of the center of mass from the y-axis. But if there is a particle on the other side, opposite side also, there is a particle, fourth particle here, m4 at a distance x4, and there is another particle m5 at a distance x5. That's not on the same direction. So here we can't put plus, because if I put plus m4 x4 plus m5 x5, that means they will be in this direction. Here also we want to find the center of mass of the system of particles m1, m2, m3, m4, m5 about the y-axis. That means I want to find the x coordinate of the center of mass of m1, m2, m3, m4, m5. So there are two particles on the left side of the y-axis. So there I should put minus, because they are in opposite direction, minus m4 x4 minus m5 x5 over all masses should be added, m3 plus m4 plus m5. Remember that. If the particles are on either side, we have to put minus sign also. That idea we need here, because they ask into a part, find the center of mass of this lamina about QT. So there is a mass on left side of QT, this square. There are masses on the right side of QT, the line QT, for this one and this one. So we have to use that minus sign also will be included, will be used when we find the center of mass about line QT or from the line QT. Okay, also now for a triangle, when we find the center of mass, we know that for a triangle something like this, for a right angle triangle something like this, if I draw, I'll name the same Q, U, R. This is 6A, this is 3A. So to find the center of mass, where will be the center of mass, we should connect the center of QU and R, that will be the median line. Oh, I couldn't draw. Is it? So in this, on this line, the center of mass will be at 1/3 of the this line. So I can name this as N. The total length is 3A, QU. So 1/3 of NR, somewhere here, is the center of mass J. Okay, so how to find the distance of this center of mass G from N is 1/3 of, so that means NG, the center of mass of the right angle triangle, from N is 1/3 of NR. But what's the distance of center of mass from here, the horizontal, this distance? How much is this one? This distance, how much is it? That means I need to find the center of mass about line QT. So if I draw this line from center to here, center of mass will be on 1/3 of this one, but I need to find this distance, is it? This horizontal distance. So what is the distance of the center of mass from the line QU from the line QU, this length? How much is this length, if they ask? How to find it? How much is this length? D how much? Because I need to find the distance of center of mass of the triangle QUR from the line QU, not from N, not from point N, not from point. From point N is 1/3 of, at a distance of 1/3 of NR. But if I want to find the distance of center of mass from the line QU, line, not from the point. Okay, so I need to find the D. So how to find it? Now consider the triangle. Imagine this triangle, I don't need to consider this one. So in this triangle, there I can imagine two triangles. So forget about this portion. Okay, so there I can imagine two triangles. One is UNR, UNR, and the next triangle, this is N, this is P, that is next triangle PNG. One, the first triangle UNR and the other one PNG. This line is parallel to this line. So the triangle PNG and the triangle UNR are similar triangles. Is it? So I need to find the distance of center of mass of the previous triangle. I raised that line. I don't need it now. I need to find the D. Is it? So here the triangle PNG and triangle UNR are similar triangles. Therefore D over parallel distance D over 6A is equal to NG over NG over NR. NG over NR. But NG over NR is 1/3. NG over NR is 1/3 because G is at a distance of 1/3 from N. So that is 1/3. So D is going to be 2A. So the distance of the center of mass of the triangle QRU or the triangle UQR is at a distance 2A from the line QT. So I'll use that later, 2A. Okay, so in the question, they are giving the mass per unit area of PQUV is K, mass per unit area of this square is also K, but the mass per unit area of the triangle is 2K, they are telling it 2K. Okay, so we need to find the center of mass of this lamina from the line QT. Okay, we'll find it, sigma mi xi, sigma mi. Okay, so we'll find the mass of this one PQRS, PQUV, yeah, mass of PQUV. Let it be M1 is equal to area 3A into 3A, 9A squared into K. K is the mass per unit area. Area into mass per unit area, that is M1. Then mass of URST, mass of URST, that is M2. That is this area, 6A into 6A, 36A squared into K. Mass per unit area is K. Okay, right. Then mass of the triangle, that is QRU, mass of QRU, that we'll call M3, that is area half into base 6A, I'll write it here, M3 equal half into base 6A into height 3A into mass per unit area 2K, it's given. So solve it, you will get 918A squared K. Right. Okay, so we'll take distances of center of mass, each of them, from the line QT. We are going to find the center of mass of this lamina from QT. Okay, so the total mass or mass of the lamina, total mass is equal to M1 plus M2 plus M3. So total mass we can call capital M. So capital M is going to be M1 plus M2 plus M3, add it, M1 9A squared, M2 36A squared, so it's going to 45A squared, 45, 63A squared K. That's the total mass of the given lamina. Okay, so we'll use sigma mi xi over sigma mi equal x bar, or sigma mi xi equal x bar into sigma mi. Anyway, that's the same thing I'm going to use then. That is sigma mi xi is equal to total mass sigma mi total mass into x bar. X bar is the distance of the center of mass from QT for this lamina. Sigma mi is the total mass, this one. MIXI, mass of this triangle, into its distance of center of mass from the line QT, plus mass of the mass of the square into distance of the center of mass of the square from QT, plus mass of the triangle into distance of the center of mass of the triangle from QT, mass of the square, this one, into distance of the center of mass from that. But there will be minus sign because these two are on one side. I'll take it plus, this will be on the other side. Right, so I'm going to use that principle here. So we'll use it. So then we'll, that is for this triangle, we'll start from this one, M1, we put it M1 into 3A, because center of mass of this square from the line QT is at 3A, is it? This is 6A, means at the center part, so 3A, plus M2 is for 36 A squared, so 36A, QRST, that is QR, mass of QR, I think I mean it's a mass of URST, I think URST, sorry. This is mass of URST, yeah, URST is the square. Mass of PQUV, PQUV is M1, that's on the left side. So we'll start with this this one. Okay, for this square, that is mass is URST, that is M2. We'll start with M2 because I'm going to put this minus sign. M2 times 3A, M2 is this square, its mass into distance of center of mass is 3A, plus for this triangle, that is M3 times the distance. I already explained 2A. I already drew and explained that by using the similar triangle. So distance of the center of mass of this triangle from the line is 2A. This distance is 2A. I already explained that. So that is 2A minus, for this one it's on the other side. So minus M1 into its distance of center of mass from the line QT is 3A by 2 center. So this is 3A, half of it, 3A by 2 equal capital M, that's a total mass, this one, into X bar. We need to find the X bar. Okay, now substitute M2, how much is it? 36A squared K. Yeah, that is 36 A squared K into 3A plus M3, that is 18A squared K into 2A minus M1, that is M1 9A squared K into 3A by 2 equal capital M 63A squared K into X bar. Okay, solve it carefully. There are a lot of A's, K, everything. We have to solve it. Carefully solve it. You will get the final answer. There X is equal to, so here you can divide the whole equation carefully. Yeah, by 9A squared K, I think you can divide whole equation by 9A squared K. Yeah, here 7 will come, no? So 9A squared K, if you divide, try that way, divide the whole equation by 9A squared K. So this 9A squared K means there will be 46, 9, 4, 12A will be there. So 9A squared K means 12A will be there, is it? Here if you divide by 9A squared, so here will be 2 into 2, 4A. Yeah, 4A minus 9A squared gone, so 3A by 2 is equal to 9A squared K, so it's going to be 7X bar. Okay, solve the left side, you know. Finally, X bar will be equal to 29 over 14. Okay, that's the distance of center of mass from QT. So it's on the left side or right side? It's on the right side because I took right side center of distance of right side of the center of mass as positive, left side for this triangle I put minus. But I am getting answer positive, means it's on the right side of QT. If I get minus answer, it's on the left side. Because I took left side, if the center of mass of the one of the given object is on the left side, I took it minus. But I end up with positive, means on the right side. Okay, B part. Show that A part we did it, 29/14A, yeah, that we got it. B part, the template is freely suspended from the point Q. So they are hanging it from the point Q and hangs in equilibrium with QR at theta to the downward vertical. Find the value of theta. Okay, so you know that when you have a non-uniform object and when you hang it from a point, the point where it's hung and the center of mass will be exactly on the same vertical line. Say for example, if there's a non-uniform shape object, something like this, its center of mass is here G. If you hang it from this point P, what will happen? It won't stay like this. If you freely hang it from here or suspend from point P, it won't stay like this because the total mass or the weight of the object is acting at K, so acting at G. So the weight is acting here. So if you hang it from here due to clockwise moment, it will rotate until the moment about P becomes 0. What will happen? It will rotate such that, so this is the point P, until the G comes below P. Until the point G comes exactly below the point P. Until that it will rotate, because due to the weight there will be a anti-clockwise moment. So it will rotate until G comes exactly below P. Okay, same way, for example, if we know the center of mass, if we know the point at which the whole mass is acting, point at which the weight of the lamina given is acting, then what lamina? I don't know, we haven't found it. We found only the distance of the center of mass from line QT. That means we don't know where is the center of mass actually. We know from this line it is at a distance of 29/14A. 29/14 means around 2.07A. 2.07A means from here, from this line, 2.07A. It could be here or here or here or here somewhere. If I draw a vertical line which is at a distance of 29/14, the center of mass is on this line, but I don't know exactly the point at which the weight is acting. I know only the distance of the center of mass from the line QT, not the point where the weight is acting. So the center of mass is somewhere on this line, which is at a distance 29/14A from the line QT. So I need to find the center of mass, the exact point of the center of mass. Okay, we'll find it there. Before that, okay, for example, if I know I found the center of mass, exactly at which point the center of mass is there. For example, if it is here, this is the center of mass, point, not exact point I found it. So if I find it, then when I suspend the lamina from Q, what will happen? The point G will come exactly below Q, so it will rotate. So it will rotate, the QR also will rotate, G will be exactly below the line Q. So if I draw a line from Q to the center of mass, this line will be vertical. Question is, we need to find the angle of QR with vertical. They are asking, that's a question, is it? They are asking to find the template is freely suspended from the point Q and the hangs in equilibrium with QR at theta to the downward vertical. QR with theta to the downward vertical. So QR with theta, so QR theta with downward vertical means which line is going to be the downward vertical? The downward vertical is QG. G is the center of mass. QG is the vertical line. With that, QR is making angle theta. So I need to find angle theta that makes with QG. If I find the G, the exact point, then I can find the theta which makes an angle with QG. Okay, right. So I need to find the exact center of mass. Okay, how can I find it? Say for example, if I know the distance of center of mass from a line, say for example, just I'll take a non-uniform object, something like this. For this object, from this line, the center of mass is at, for example, the center of mass is at 2 centimeters from this line. Means if I draw a 2 centimeter line from this vertical straight line, center of mass will be somewhere here along this line. So the whole line, the blue color line, is at 2 centimeter, 2 centimeter, 2 centimeter from this line. I can call QT. From this line QT, this line is at 2 centimeter. Means the center of mass will be somewhere on this line, but I don't know still exact point. How can I find the exact point? Again, I need to find the center of mass from another line which is perpendicular to QT. So if I take and find the center of mass from another line from here, for example, if it is QS or something like that, and when I find the center of mass from the line QS, if it is at a distance of 6 centimeter, means from this line QS, it will be at 6 centimeter, means 6 centimeter from this, 6 centimeter from this, means if I draw a line at 6 centimeter from this QS, there will be the center of mass. So when these two lines intercept, the center of mass is exactly at this point. So such that the same way for this lamina, I am going to, already I found the distance of the center of mass from QT. Now I am going to find the distance of the center of mass from PQ, from the line PQ, this extended horizontal line. From PQ, if I find the distance of the center of mass by using the same method, then I will be able to find exact point of the center of mass. Okay, so again we have to do the same working to find the distance of the center of mass from the line PQ. PQ means a horizontal line that passes through P and Q, a straight line. From this straight line that passes through P and Q, we will find the distance of the center of mass. So where it comes, that will be that line, and this line, which is from here, we found it already, which is 29 over 14a. Then from here we find it, those two lines intersect, that point is the exact center of mass. Okay, so now we are going to find the center of mass of this lamina from the line PQ. So extended line PQ along this line. From this line PQ, we are going to find the center of mass. We already found it in the part, that is distance of the center of mass from the line QT, which is 29 over 14a. I drew a vertical red color dotted line. So the center of mass will be somewhere along this dotted line. Now we need to find the center of mass, the same center of mass from the line PQ. Okay, so here all the masses are on the same side of line PQ, so there won't be any minus sign when we find sigma mi(xi). Okay, now the problem here, finding the center of distance of center of mass of the triangle QUR. So to find the mass of the QRU. Okay, so again I will explain separately how to find the distance of the center of mass from the line PQ. I'll draw the same triangle again. So same U, Q, R. So this is 6A. So when I consider median from UR to Q, so that will be center, it's like this, is it? So center of mass will be at 2, if I say this center point N, the center of mass will be here, 1/3 of line QN. So center of mass will be somewhere here G, or 2/3 of line QN. QG is 2/3 of QN, or GN is 1/3 of QN. Okay, so I need to find the distance of G from this line, is it? From this line. So that means I need to find the distance of G from Q like this way. So imagine a triangle this like, this is G, this is N, let it be P, right? Now consider the similar triangles, QPG, and Q, U, N. So this length is 3A. So this Q, UR is 6. UR is 6A. This is going to be 3A. So this is 3A. UN is 3A. This portion I don't need. This part I can erase it. So my aim, this is the center of mass of this triangle at G. I need to find the distance of G from here, from this line. That means I need to find QP. Right, okay, so in this, these are the two similar triangles, QPG and QUN. Okay, so QP over QP over QU is equal to QG over QN. QP over QP over QU. Okay, how much is it? QP is the thing I need to find it. Let it be D. QP I need to find it. QU how much? QU given 3A. This is 3A. This is 3A square. So this is 3A. QU is 3A. Is equal to QG over QN, QG over QN, that is 2/3, because this is the center of mass of the previous triangle QUR. For this triangle, this is the center of mass, so this is 2/3, so this is 2/3. So how much is D? D is going to be 2A. So remember that center of mass of this triangle from the line PQ will be at distance 2A. Okay, so I'll use that here. Okay, so we'll find the center of mass of this again from the line PQ. That is this mass M1 is for PQUV, PQUV. So M1 into distance of this center of mass from the line PQ is 3A/2 plus center of mass of URST, this is ST, that is M2 into the distance. This is the center of mass of this square is at 3A from this line. This is 3A, so that will be, this is 3A, this is 3A. From PQ, the center of mass of the square URST will be 3A plus 3A, 6A. Plus M3. M3 is for the triangle into the distance of the center of mass from the line PQ. Just now I showed it 2A is equal to total mass. We found it earlier. Add all these 63, yeah, I'll put it as capital M into Y bar. We'll find the Y bar. We'll find the Y bar. So Y bar is the distance from there. Okay, capital M is 63 A squared K. Okay, now M1, M2, M3 we know that. Substitute M1, that is 9A squared K into 3A/2, M2 36A squared K into 6A, M3 18A squared K into 2A equals 63A squared K times Y bar. Okay, solve it again, divide whole thing by 3A square, and when we solve it finally, you will get Y bar is equal to 59A over 59A over 14. So that means almost more than 3. 3 means 52, so more than 3. So from here, more than 3A, somewhere again, this is 3A, so more than 3A means if you draw a line horizontally like this at a distance 59 over 14A, that line, and already I drew a red color line, they intersect. This is going to be the center of mass. This point is the center of mass. So we found the center of mass now. This is the center of mass G. So this center of mass is at a distance from here, from this line, 29 over 14 from this line. That means from here I can draw it like this. Now I'll erase these things we don't need. So this distance this distance 59 over 40. So I can erase these things now, I don't need it. 59a over 40. This length 29a over 40. Okay, now when I hang it, what's going to happen? When I hang it, G will come vertically below Q, so it will rotate. I need to find the angle between QG. If I connect these 2 points, Q and G, I need to find this angle. This is theta. This is theta. Okay, so now everything we know that. We know this angle. So when you consider this U, this is point U already there. This point U is there already. So in the triangle UQR or UQR or QUR, the angle Q is equal to tan inverse UR, that is 6A, this length 6A over QU 2A. Am I right? In the triangle QUR, this angle Q, in this angle Q is equal to tan inverse opposite over adjacent. So 6A or 2A, that is tan inverse 2. If you find tan inverse 2, that will be equal to 63.4 degree. 63.4 degree. Now find this angle, this let it be alpha, this angle alpha. In this triangle QG, this point here, if you consider this triangle QG, this point let it be N. In the triangle, this point where the line horizontal cuts, in the triangle QGN, because this is the line, will become vertical. With that line, we need to find the theta. So the center of mass is here. This length we know 29 over 14. This line length we know 59 over 14. So this point is N. So in the triangle QGN, this angle tan alpha is equal to opposite this length, that is 29A over 14, 29A over 14 divided by 59A over 14. So that's going to be 29 over 59. So alpha, find the tan inverse 29 over 59, that will be 26.2 degree. Okay, so I know the whole angle, that is 63.4. I know the alpha, this angle I know. I need to find the theta because they asked to find the QR with vertical, means when you hang, the line QG will become vertical. With that, what's the angle of QR is the question. So I need to find the theta now. So simple, Q theta is equal to 63.4, that's the whole angle, minus alpha, that is 26.6. So I'll write here the final, the theta is equal to 63.4 minus 26.2. So that will be 37.2 degree. Lot of working, but interesting question, is it? Okay, question number 8. This diagram is given. Figure 4 shows a rough ram fixed to horizontal ground. The ram is inclined at angle alpha to the ground. Tan alpha 1 over 6 means we can find sine and cos by using right angle triangle. The point A is on the ground at the bottom of the ram. Point B is at top of the ram, which is 4 meter away. AB is a line of greater slope and ramp AB 4 meter, A to B 4 meter. A particle P of mass 3 kg is projected with a speed u meter per second. So a particle is projected from here at u meter per second, uh, 3 kilogram from A directly towards B. The coefficient of friction between the particle and the ramp is 3 by 4. So mu is 3 by 4. Find the work done against friction as P moves from A to B. So here there will be friction. So the friction is due to the limiting friction because the particle is in motion. So the friction acting on the particle will be the maximum friction. So it's going to be the limiting friction. So the limiting friction is given by mu r. So if an object is kept on a inclined plane, which makes an angle alpha, the weight is acting vertically down mg. The normal reaction will be along this direction. So this angle is, this is 90 degree, this is 90 minus alpha. Compound of the weight perpendicular to the slope. You can resolve this weight perpendicular to the slope along the slope. Both directions you can resolve it. The compound of the weight perpendicular to the slope is mg sine 90 minus alpha. This is 90 minus alpha. Mg sine 90 minus alpha, that is mg cos alpha. Compound of the weight along the slope down is mg cos 90 minus alpha. This is 90 minus alpha. So mg cos 90 minus alpha, mg sine alpha. If there is no motion away from the slope, that means there is no motion away from the slope, means along this direction, no motion, no acceleration, means r minus mg cos alpha equal to 0, r equal mg cos alpha. So remember that whenever a particle, an object is kept on an inclined plane which makes an angle alpha, the slope makes an angle alpha with the horizontal, the normal reaction is given by mg cos alpha. When there are no other forces acting, only the weight is acting, the normal reaction is given by mg cos alpha. Remember, you can apply that directly. Okay, so the particle is moving along the slope up 4 meters, AB is 4 meters. So the friction acting on the particle is equal to Fr. It's a limiting friction. I already told why is it limiting friction, because the particle is moving, so the friction is going to be the maximum friction, which is the limiting friction. So the friction, so A part, find the work done against friction is the question. The friction Fr equal to mu r. So that is mu is given 3 by 4. R is equal to mg cos alpha. Okay, we know tan alpha is given 1 over 6. If you think about the right angle triangle, 1 over 6 is the right angle triangle, tan alpha 1 over 6. So this is going to be Pythagoras theorem, 36 plus 1 square root of 37. Okay, so cos alpha is going to be 3 by 4 mg. So mass is given, I substituted mg cos alpha 6 over square root of 37. Okay, so work done against friction is the question. So work done against friction equal friction into distance moved opposite to the friction. Friction force into a distance moved opposite to the friction. So the friction force is this one, Fr, into distance moved opposite to the friction is AB, which is 4 meters. That much of joules. Okay, so that is 3 by 4. Mg mass is given 3 kilograms, so 3 into 9.8. So 3 into Fr, I found 3 by 4 mg, 6 over 37. So 3 by 4, m is 3, g is 9.8 into 6 over square root of 37. Okay, so that will be into 4 joules, this 4. Okay, solve it. 3 by 4 into 3 into 9.8 into 6 into 4 divided by square root of 37, 87 joules. 87 joules is the work done against friction. Okay, B part, given that at the instant P, reaches the point B, the speed is 5 meter per second. So it was projected at u meter per second. When it reaches P, the speed is 5 meter per second. By using work energy principle, so you can't use Newton's second law, work energy principle, find u. Okay, for that I need the vertical distance it moved. The vertical distance it moved when it moved from A to B, that is going to be 4 in this right angle triangle, 4 sine alpha. So sine alpha we can find it by using the right angle triangle. So we know cos alpha, we found it, they are giving the tan alpha is equal to, they are giving tan alpha 1 over 6. Sorry. So here this is alpha, tan alpha 1 over 6, this is root 37 means sine alpha 1 over square root of 37. 1 over square root of 37 is the sine alpha. Okay, so here what's the energy equation, B part? When it moves from A to B, it was projected. So when it moves from A to B, it's going to lose kinetic energy. So the loss in kinetic energy will be converted into gain in gravitational potential energy and work done against friction. So loss in kinetic energy is going to be gain in gravitational potential energy plus work done against friction. Loss in kinetic energy, initial kinetic energy, half mu squared minus half mv squared, that is the loss in kinetic energy. Gain in Gp, mgh, h is 4 sine alpha, plus work done against friction, you already found it, 87. Okay, substitute, and you need to find only the u. So half, mass is 3, u squared minus half, 3, final speed 5, so 5 squared is equal to 3 into 9.8 into h is 4 sine alpha, 4 sine alpha, h is 4 sine alpha, I showed it 1 over square root of 37, so 4 into sine alpha, 1 over square root of 37 plus 87, this 87 comes in. Okay, everything we know except u. Carefully solve it, you will get the value of u. That will be equal to 9.80 meter per second. Okay, part C now. So part C says that the particle leaves the ramp at B and moves freely under gravity. So when it reaches the edge of the ramp B, it's going to follow a projectile motion, because at the moment it reaches B, its velocity will be along the ramp. That makes an angle alpha with horizontal. So it's going to follow a projectile motion. The initial velocity is 5 meter per second along the ramp, that is with horizontal. The initial velocity is 5 meter per second. That is given in the question B, part B. 5 meter per second, final velocity at B is given in the second part. Okay, it's going to follow a projectile motion. So the height, finally it's hitting the ground at point C, means C and A are along the same line. We need to find the distance from B to C, horizontal distance, we need to find the D. Okay, so the height is going to fall down from B to C. C is in the ground level, h sine alpha. So h sine alpha is equal to, h is equal to 4 sine alpha. It's going to fall down. H is equal to 4 sine alpha. That is 4 into sine alpha 1 over square root of 37. That will be 0.66 meters. Okay, for the motion from B to C, downwards use S equal ut plus half at squared. Okay, S is 0.66. U is 5 sine alpha, which is minus, because I am using downward direction, but this is upward direction. So 5 sine alpha, which is minus, into t, plus half into 9.8 t squared. substitute sine alpha, which is 1 over square root of 37. So that is 0.66 equal to minus 5 into 1 over square root of 37 t plus half into 9.8 t squared. So it's a quadratic equation. Solve it. You will get a quadratic equation finally 4.9 t squared minus 0.82 t 0.82t, solve it carefully, 0.82t minus 0.66 equal to 0. By using calculator, solve this quadratic equation, you will get t is equal to 0.46 seconds and t is equal to minus 0.29 seconds, which is less than 0, so invalid. So the time is positive quantity. So now use horizontally, s equal ut plus half at squared. For the motion b to c, so that s b to c, the horizontal displacement d is equal to 5 cos alpha into time 0.46 plus half, horizontally no acceleration because gravitational acceleration is vertically down, that has no horizontal component, no friction, so 0. Cos alpha, we know 6 over square root of 37, 5 into 6 over square root of 37 into 0.46 meters. Solve it. The horizontal displacement 2.27 meters. Okay, so that's all. I discussed all the questions on June 2022, Edexcel IAL, Mechanics, Mathematics, Mechanics M2 paper. I hope you understood. Yes, we'll meet during another discussion, some other paper or some other theory. Bye.